So like any hypothesis test, when we're testing two population proportions, you're going to have some assumptions. Our assumptions here are going to be pretty basic. We have two independent samples and at least 5 successes and at least 5 failures in each of those samples. Beyond that, it's going to be pretty much a traditional approach. State the null and alternative hypothesis, decide on alpha, input your data, or set up a critical region. If you're doing things with the classical approach, get a p-value or get a test statistic, reject H0 or fail to reject H0. That's your decision you have to make here. When are you going to reject H0? What has to happen? Anyone?
P is less than alpha.
P is less than alpha. If your p-value is low, H0 must go. And the last but not least, state your conclusion in words. All right, so let's give that a shot. And the first one actually has some history, that part of which took place in Michigan. Typical of the work on my stat lab, they kind of made the problem a little bit more boring than it's supposed to be. Because they don't talk about what disease it is that they treated with all these children. That's a big study. 400,000 kids in one study? Wow. Well, they're testing the polio vaccine, the Salk vaccine for polio. This is back probably in the 50s, I'm thinking. It's probably why we don't hear much about polio anymore. I did have a colleague of mine that worked here for us years ago that survived polio, but he was one of the lucky ones. A lot of kids didn't. In any case, it says a large clinical trial, 392,062 children were randomly assigned 2 groups. The treatment group consisted of 198,630 children given a vaccine for a certain disease, that would be polio, and 35 of those children developed disease. The other 200,432 children were given a placebo. Of those, 122 developed the disease. So let's take down a little data here for ourselves, because we're going to need it. We're going to have to input this ourselves. So let's see. Let's do it this way. Leave a little room for your original claim and HO and HA. Let's look at, we're going to have a treatment group and a placebo or control group. So basically, if we did nothing, how many people would get the disease, as opposed to putting in some kind of an intervention? Now, looking at the numbers here, we had 35 kids who got polio despite the fact that they got the vaccine, of 198,630. For the kids that didn't get the vaccine, there was 200,432 children that didn't get the vaccine, and of those, 122 contracted the disease. Now I can write p hats of 1 here. What do you think p hat is going to equal in this case? How am I going to calculate that?
35 divided by 198,630.
Yeah, 35 divided by 198,630. Thank you. Now when you do that on your calculator, unless you've used this in a while, you might get something that looks a little strange, a little funny. Let's take a look at that. 35 divided by 198,630. And I get this. I get 1.762. Call it 762. Yeah, 762. That looks kind of funny. Until you look all the way at the right end of this. It says E negative 4. What's that E negative 4 all about? It's really scientific notation. It means times 10 to the negative fourth power. Now, do you expect this to be a really big number or a really small number? It should be small. So if I'm going to put this in decimal notation so I can better look at it, then am I going to move the decimal to the left or to the right if this is going to be a really small number?
Left.
To the left. So 0. Now, once I move it one place, I don't have any more digits to move past. So the rest of them are going to get filled out with zeros. So that's your p hat. It's a really small proportion. A little bit less than 2 kids out of 10,000. What's p hat sub 2 going to look like? Dimitri?
122 over 200,432.
Nice. And let's take a look at that probability as well. So 122 divided by 200,432. So 6.086. Do I got a typo here someplace? 60. Yeah, we'll call it 6087 maybe, round it off, times 10 to the negative fourth, 4.006087. So let me switch back to where I'm writing. So which one looks like a bigger probability? I mean, they're both really small. Polio was thankfully relatively rare, but when you're applying it to millions of children, that adds up. These probabilities add up either way. But where would you rather take your chances? Here or here? Treatment or control? Yeah, from the way I see it, I mean, you just kind of cover this up. 60 is more than 3 times what this is. So, yeah, this one's looking a little bit more risky. Now, there's some more notation here that I want to get you comfortable with. And that is something called P bar, which is going to be the overall kind of rate of success in air quotes, x1 plus x2 over n1 plus n2. P bar is going to be 35 plus 122 divided by 198,630 plus 200,432. So that's going to be 157 in the numerator and 399,062 in the denominator. So that's P bar. If you did that on your calculator, that's going to be about 3.934 times 10 to the negative fourth. Kind of a small number.
Can you lift up your paper?
This one?
No, the other. That one.
That got what you need?
No, a little bit more down.
Good? All right. So this is P bar. And let me calculate that on my calculator. So let's clear this out and this out. So I've got 157 divided by 399,062. All right, so 3.934. How do you think I'm going to get Q bar?
1 minus.
Yeah, it's going to be 1 minus P bar. Now, if you're working on a TI 84 or 83 graphing calculator, there's a nice friendly way to do this. You can just do 1 minus your previous answer, this thing. And instead of typing that in, I'm going to hit the second key, then the answer key. So second, and then this opposite key down on the bottom of your calculator, that takes that number and puts it in here. So P bar, or excuse me, Q bar is 0.09996, approximately. Okay. So that's just practicing some of the notation that you might be asked for some of the problems as you work through your homework. Are we okay with the notation? I think we got everything set.
I have a quick question on when we calculate it out. So are we moving the decimal place over 4 because of the -4 on the right side there?
Because of the exponent, yeah, because of the
So if
-4.
it's a 5, we move it over 5 times then?
Exactly. If this was a -5 here, then you move it over 5 places to the left. And once you get past this, you start adding zeros for every decimal place that you add.
Alright, thank you.
Thank you. Okay, let's go back and take a look at the problem here. A lot of the stuff was just notation part. So the first thing we have to figure out is what's the original claim. And they pretty much tell you right here, it's part A. We're going to do a 5% significance level to test the claim that P1 is less than P2. Okay, there it is. P1 is less than P2. Here's your P1. Here's your P2. P1 is a treatment. P2 is a control. They literally tell you that in the problem. And they tell you that your original claim is P1 is less than P2, meaning your probability of getting polio with the vaccine is lower than your probability of getting polio without the vaccine. That's what they're stating here. Esther, where does that claim go? Where am I going to put that in my hypothesis?
Alternative?
Yeah, P1 is less than P2. Good. And Anthony, where's that going to go in terms of, or what's going to be in my null hypothesis?
P1 is greater than or equal to than P2.
Nice. And Grace, when we do this in StatDisk or StatLab, this isn't going to be one of my choices. What will I have to use instead?
Then P1 will be equal to P2.
Yeah, P1 equals P2. Nice. All right, thank you both. Let's see, so that's our original claim. I'll circle that. Let's do our hypothesis test, which I think is what we're being asked for in the first part. Which is better? Hypothesis test or confidence interval? I'll talk about the confidence interval when we're all done. Let's go to StatDisk. Where should I go once I get to StatDisk? I don't want to do a hypothesis test for one standard deviation anymore. Where should I go?
Analysis,
Analysis,
hypothesis test,
hypothesis testing.
proportion, 2 samples.
Beautiful. Proportion to samples. Awesome. The first thing I got to do is I got to fix the alternative hypothesis. So population proportion 1. How's that going to compare to population proportion 2? Which one of these do I want? 3. I want the first population to be less than the second population. That's great. Significance level will leave at 0.05. I don't know why, but I always get these mixed up. I want to put in X first and then N, but that's not the order that they want us in. So right here, my sample size for the first population is 198,630, and of those, 35 contracted polio. Down here for 200,000, 432 of those 122 contracted polio. And when you're ready, hit the evaluate key. Bam. All right, so let's see. Let me start afresh on a new sheet here. 8. So running through our steps here, kind of those generic steps, those things that we're going to do when we do any of our hypothesis tests. Our null hypothesis was this. Here was our alternative. Alpha was 5%. We input our data. What do I want from the screen that I just popped up right here? What is it that I need? What am I looking for? The p-value, yeah. And the p-value is a straight nothing, 0. So what I want you to do is take a minute and decide what we're going to do with the null hypothesis. Are you going to reject H naught or fail to reject H naught? Take a minute and think about it. Those of you on Zoom, put something in the chat. See if you agree with your neighbors. See if you agree with your other Zoomers. Here, my roomers, check with a neighbor. Do you guys agree?
Yeah, so reject.
The fact that P is 0.
As long as P
Zero
is
is
less
less
than
than 5.
alpha, reject.
All right, pretty unanimous online. Let's see what we're gonna get. Let's see what we're gonna get here. Adel, what'd you decide? What'd you think? Reject? Do you agree with Philo? All right. So the question is P less than alpha? Is that true? Yeah, that's definitely it's a no-brainer. 0 is less than 0.05, that's true. So if P is low, H naught must go. So reject H naught. And now it comes time to figure out how we're going to state our conclusion in words. Keep in mind that this was our original claim. Right here. So let's look at this and try and decide. Does your original claim contain the condition of equality? No. All right. Did we reject? Yes. So the sample data support the claim that, and then you got to state the original claim in words. So that's the tough part. By the way, you don't get any points for copying this down. You get points for, stating the original claim in words, that part of it. So the sample data support the claim that sample data support the claim that the treatment, and there's two ways you can say this. You can say that the treatment is effective. I kind of like this because it's very user-friendly. People can read that and understand what you mean. If you want to be a little bit more in line with the actual thing that it's saying, that is the rate of polio among the treatment group is less than that rate amongst the control group. So the rate of polio among the placebo group. Now there's a follow-up to this that we'll go over in just a second. Are we okay with our conclusion though? The wording of our conclusion, how you get that? Let me do the little bit of follow-up here. I'm going to go with the book's version of this. That is P1 equals P2. And I want to do a little bit of algebra here. I know this is a stat course. You didn't choose this because you want to do algebra, but we're going to do just a little bit of algebra. Tiny little bit. What if I was to subtract P1 from both sides for this equation? Actually, you know what? I'm sorry. Let me subtract P2. Let's subtract P2 from both sides. What equation is going to pop out? Well, it's going to be the right-hand side. Zero on the right-hand side. P1 minus P2 on the left-hand side. And that's it. That's all the algebra we're going to do, okay? All right, so we're back to our regularly scheduled program. So I could write it this way, or equivalently I could write it this way. P1 minus P2 equals 0. Those are the same thing. They mean the exact same thing. So one of the things you can look at when you're all done is a confidence interval for this difference. Where is that difference? How big of a difference is there between these two? My question to you, based on the data that we have here, is will 0 be in this confidence interval? In other words, will I go from negative to positive or positive to negative? Is 0 going to be in my confidence interval? Should it be? And think about the fact that we rejected our null hypothesis. Should 0 be in the confidence interval? What do we say about H naught for this test? Anthony? You don't know what we said about H naught in this test?
Since we rejected, shouldn't like the 0 not be part of it?
Okay. We rejected this possibility, right?
Yeah.
So 0 shouldn't be as part of our confidence interval. Because if 0 was part of our confidence interval, then we're saying that H naught is possible. But H naught shouldn't be possible because we rejected that. So your confidence interval should match what your hypothesis test is saying. It should tell you the same thing. Now there's rare instances in which that may not occur, but by and large it is going to occur. So to finish this up, let's take a look here. Let's take a look at our confidence interval. Here's your confidence interval, and it does not contain the possibility of equality. So it's negative 0.00054 or negative 0.00033. So somewhere between 54 kids in 1,000 and 33 kids in 1,000, less, not 1,000, 100,000, less cases of polio will occur according to this analysis. So, but the big thing is it does not contain 0. Does not contain 0. Wade into that. Get comfortable with this, because one of the things I can do on your upcoming test, and I don't think it's like next week, but one thing I can do with your exams is I don't have to write them so that you use StatDisk. I could just say, okay, here's the problem. And oh, by the way, when you got a confidence interval, this was the confidence interval. And then I ask you to decide what you would do with H naught. If your confidence interval contains 0, oh, then you would fail to reject. If your confidence interval doesn't contain 0, then you would reject. Simple as that. Or I could give you a p-value, and again, ask you to make decisions about H naught, whether it's to be rejected or you fail to reject. So it's a way around having to work with StatDisk and Google Sheets on every exam. So just be aware that that is a possibility for me. We'll see how it goes. I haven't thought much about the next test just yet, but I am giving you a heads up that that is something I can do. Comments or questions on that part? Jaren, you hanging in there? All right. Grace, we're good? Let's do one more to finish this up.
Are you ever gonna ask for p-bar?
So p-bar, what that is it's kind of like the overall average. It's the average between the two groups. That's actually something that you would use if you were stuck calculating the test statistic itself. I think the test statistic is based on a z. So if you plot here, this is your typical standard normal distribution. The point on the standard normal distribution with 5% of the area in the left tail is this one. Well, we got a test statistic of negative 6.88. That's way out here. It's so far in the rejection region that the p-value is essentially 0. So the smaller p is, the more confident you are about rejecting H naught. We can be really confident in rejecting H naught in this particular case. But as far as p-bar and q-bar itself is concerned, unless you're actually programming your calculator or StatDisk to do this, then you're not going to have to calculate p-bar or x-bar. The reason I included that is because I think it's one of the problems that you're going to face. So it's a good question. I appreciate that. All right, last one. Let's see. Example B here is just notation. So let me just kind of read this. I want to choose either example C or example D. Okay, let's try this one. Where is it? Amongst 2,036 passenger cars in a particular region, 221 had only rear license plates. So let's write that down, kind of take care of that. And then amongst 390 commercial trucks, 56 had only rear license plates. A reasonable hypothesis is that commercial truck owners violate laws requiring front license plates at a higher rate than owners of passenger cars. Use a 1% or 10% significance level to test that hypothesis. So, okay, they're not saying much about how the sample was obtained. So, we can't say much about that, but it is telling us that we've got at least 5 successes and 5 failures amongst those two. So let's see if we can't do something here. Let's see. The population 1 correspond to the passenger cars. So it'd be cars is P1 and trucks is P2. And let's gather a few relevant statistics. X1 and N1, X2 and N2.
Excuse me, do you have tissues up here by chance?
Sorry, I don't. So as far as X1 is concerned, that's from our passenger cars, 221 had only rear license plates out of 2,036. For trucks, those numbers were 56 for X2 and 390 for N2. So if you want to kind of quick glance at my sheet here, looks like this so far. So this is example D. A reasonable hypothesis is that commercial truck owners violate laws requiring front license plates at a higher rate than passenger cars. So we're gonna have to try and figure out what we're gonna write in terms of an original claim. If they violate laws at a higher rate, now I'm assuming that you have to have both a front and a rear license plate. So it means their rate of having only a rear license plate would be higher. So commercial truck owners violate laws requiring front license plates at a higher rate than owners of passenger cars. So our original claim is going to come down to a P1 and a P2. What symbol am I going to put in between these if it's going to match? I'm going to vote for less than. Adel and Philo are giving me nods of agreement. Keisha, well done. Yeah. The rate at which they violate these laws is higher than the rate of passenger cars. Okay, that's fine. No judgment zone. Let's just do the problem. If P1 is less than P2, where's that going to go? HO or HA?
Okay.
HA. Nice. Now, I think they said alpha was 10%, right? We're going to change that. I'm tired of 10%. We'll do 5%. 5% and 1%. Those are the only values you're going to see in the statistical literature. 3, we want to input our data. So let's input these numbers into StatDisk. Let's see, our alternative hypothesis should be which one of these 3? 1, 2, or 3? 3. P1 is less than P2. Significance level of 0.05. 2036. Of those, 221 had only rear license plates. Of the 390 trucks, 56 of them had only rear license plates. All right.
Where did you get the significance?
I changed it. The problem said 10%. I changed it to 5% just because I don't like 10%. No one ever uses 10%. I get why the book does it, but I just changed it to something that's more typical of what you'll see if you read peer-reviewed articles and journals. So, all right, so we input our data, that's number 4. Jacqueline, what am I looking for from this output here?
P-value.
Yeah, the p-value. So the p-value in this case is 0.0231. What decision is that going to make for us? Ben? Here's your p-value. What decision were you going to make based on that p-value?
Reject.
Good, let's reject H0. And then step 6, we have to state our conclusion in words. So let's go back to our little sheet here. And let's also remember our original claim was this one. So on that first branch, are we branching to the right or down? Down, because the original claim does not contain the conditional equality. Did we reject? Yep. The sample data support the claim that, and then you have to state the original claim in words. So sample data support the claim that, and my inclination is to say trucks violate the laws requiring front license plates at a higher rate than the owners of passenger cars. So just picking this right off of the problem itself. So I'm just going to copy down what I have highlighted in green, that truck owners violate laws requiring front license plates at a higher rate than owners of passenger cars. Okay. Did our confidence interval contain 0? Did anyone notice that? Should it contain 0? No. There is something about our confidence interval that I want to point out. Take a look at our alpha. Our alpha was 5%. Generally, that corresponds to what level of confidence when you do your confidence intervals? Usually corresponds to a 95% confidence interval, right? But if you look, we got a 90% confidence interval. If you actually wanted a 95% confidence interval, you'd have to go back here. Confidence intervals, proportion 2 samples, and then run through it this way. So the numbers you'd type in would be 221 and actually, you know what? Backwards. 2,036, then 221, then 390, then 56, and now we can get our confidence interval. This is now a 95% confidence interval. And this is at odds with our conclusion though, because our confidence interval here contains 0. Yeah, not by a lot, but by a little. But as far as this goes, this is happening because we did a one-sided confidence interval or a one-sided test. Stick with the results of your hypothesis test. And it's actually one of the answers to one of the early questions that I skipped over. You know, which one of these do you believe? I think it was in example A. Your hypothesis test is going to be better for you here. So, all right, that's it for today. Comments or questions?